All right, how's everybody doing today? Good, Friday. Okay, so we got a weekend coming up. It is the end of the 6 weeks. We're going to be starting the next section of vectors on Monday, dot products and what we call vector projections. You have the homework today. We're going to go ahead and have that due on Monday, first grade of the 6 weeks. I should be able to give you a little bit of time. We'll see how long it takes us to get through these problems. I wanted to go ahead and do another few problems like we've been working on recently, because I know some people have still been having a little bit of issue with those. And then there's one last concept I need to show you in our packet we've been working on, and then we are good to go. So example, a plane traveling 400 miles per hour is traveling with a bearing of 40 degrees. Okay, there's a wind of 50 miles per hour from the south. If no correction is made for the wind, what are the final bearing and ground speed of the plane? Okay, so if we're kind of talking about this graphically, okay, now we're going to go ahead and do this algebraically like we have been, but let's say we got the plane traveling 400 miles per hour, but it says a bearing of 40 degrees. So is that a quadrant bearing or a true bearing? That's a true bearing. Now, if it were a quadrant bearing, it would go ahead and give me something like, north, 40 degrees west. It would provide me those types of information. So remember, for true bearing, we always start at true north and we rotate all the way around clockwise. Well, we have 40 degrees, so that's going to leave me in quadrant 1. So let's say this right here represents the plane. Let's go ahead and say P. Okay, so this would be 40 degrees, and the plane is traveling 400 miles per hour. Okay, 400 miles per hour. Now, again, the wording on this is kind of unusual. It says there's a wind of 50 miles per hour from the south. So if it's blowing from the south, that means it's actually blowing what direction? It's actually blowing up, so north. Okay, so if this represents 400, let's say that this little one right here represents the wind, that's going to be 50. Okay. Now, we talked about a triangle method, earlier in the week. If I wanted to go ahead and do this graphically, I would move this little vector here so that I have an initial connected to a terminal end. Okay. So those represent the two sides of the triangle that I'm forming. Creating the third side right here, let me do this in a different color. This right here would be the resultant that we call R. Okay. Now that's basically what we're trying to find. What's the magnitude or length of R? That's the speed the plane is actually traveling. And what is the bearing measure coming off of true north? Those are the two things we're trying to find, just like the previous questions. Now again, you don't have to do this. This is just if it kind of helps you to visualize what's happening. Now here's a formula that we like to use. The magnitude of a vector, cosine theta, the magnitude of a vector, sine of theta. Okay. So let's say P represents the component form, the vector for the plane. Okay. Well, do we know the magnitude of the plane? Yeah, how fast is it traveling? 400. So here speed is my magnitude. So that's 400. Cosine what? Now remember, this is where you got to be careful. For this formula, theta has to start rotating from where? There we go, from the standard position. So even though it gave me a true bearing, we said that we have 40 degrees true bearing. Actually, what I want to plug in here is 50. Remember, theta always starts rotating from the positive x-axis. Okay, so we want to be careful on that one. So I'm going to say 50 degrees. And then I'm going to go ahead and say 400 sine of 50 degrees. Everybody with me? Okay. So let's go ahead and figure out what those are. Let's go ahead and get the decimal values. 400 cosine 50. So I'm going to say, let me get out of here. And it's doing that green thing. So let me come back over here. Okay. So I'm going to say calculate 400. Get rid of that. Delete. And it's not allowing me to do it. So I will just go over to the keyboard. It's going to make this go faster. There we go. Okay. So we have 400. It was cosine of 50 degrees. So let's say 257.1, and then we have 400 sine of 50. So let's say 306.4. So 257.1 is the horizontal value. That's A. 257.1. Okay. 257.1. And the B value, let's say 306.4. Okay. There we go. Now let's talk about the wind. Now the nice thing about the wind, remember, if it's going in a specific direction, north, south, east, or west, one of the values is going to be what? Oh, someone said it. It's going to be 0. So think about it. This guy's just going straight north, right? The component form is going to look and act just like an ordered pair, right? So let's say W is the wind. Well, what do you think its component form would be if it's going straight up? 0, 50. There you go. That's exactly right. Is everybody okay? Now, in order to find the resultant, this third side right here, okay, we're taking the two vectors I was provided, and we're simply going to add them up. Okay. So the resultant I'm looking for is going to be the sum of the two vectors. Well, how do I add the two vectors together? Yeah, A plus A and B plus B. So I'm going to add 257.1 to 0, and I'm going to add 306.4 to 50. So my resultant is going to be 257.1, and then that's going to be 356.4. Okay, remember, this is what we call the resultant. Okay, it resulted from a combination of the other vectors. Is everybody okay with that? Well, now there's only two things I need to do. I need to find the magnitude and the direction angle that this vector has. Okay. Now the magnitude, we've seen that formula many, many times. Remember, this is A, this is B. Yes. So the magnitude of R would be the square root of A squared plus B squared. So that's the square root, 257.1 squared plus 356.4 squared. Okay. Now, when I say magnitude in terms of this problem, it's actually going to give me the true speed the plane is going. Okay. So I'm just going to go ahead and plug that in here. So big square root, parentheses. I'm just going to use the decimal values. 257.1. Okay. Square that. Plus parentheses 306.4. 306.4 squared. Okay, so how fast is the plane actually traveling? I'd say 399.9. So with that decimal, I could probably say 400. Okay. So the wind really is not affecting it a whole lot, right? Did I make a mistake? Wait, did I type in the wrong number? I sure did, didn't I? I was just thinking about that. That should be 356. Yeah, because I used the original value right there. Because I was thinking, why wouldn't that have affected that? And also, I was just seeing if you guys are paying attention. So, yeah, I mean, we're good to go. All right. So, there we go. That's better. 439.5. Because I was like, that wind has to have an effect on that plane. I just completely forgot that answer. 439.5. So, 439.5 miles per hour. Okay. Yeah, I guess you could say on that problem, I was just straight winging it. Experienced a little turbulence there. It's a plane problem. There you go. You like it.
Some resistance.
Oh.
If you're like it.
Oh, there you go. Get on. Okay, one more thing. Now we got to find theta. So tangent of theta is equal to B divided by A. Okay. So here, now in order to find theta, what am I going to have to do to tangent? Take the inverse. So tangent inverse of a B, make sure I get the right number this time, 356.4 over A, 257.1, is going to give me theta, which is about, okay, well, let's see what that turns out to be. So let's see here, tangent inverse of control divide. Make sure I get the right number. 356.4. Okay. Over 257.1. 257.1. Not that 0.1. There we go. So as soon as I push enter, let's say about 54.2 degrees. Okay. But now, here's where you got to be careful. Remember, how was the original measure given to me in the problem? Well, no, that's the speed. That's the magnitude. What do we call it when you start rotating clockwise from true north? That's true bearing. Okay. We got 54.2 degrees. So if I come back over here, let me go ahead and write that out. 54.2 degrees. Oops. But that is not the answer we're looking for. This theta we just found, that was 54.2, right? You always want to make sure that the answer you give with respect to the degrees is the same form that we were given in the problem. So what would 54.2 degrees be as a true bearing? How would I find that? There you go. Andrew says we subtract it from 90. That's right. So 90 minus 54.2. Okay. And see 35.8 degrees. So if you take a look at our value here, this R, okay, hopefully this kind of makes sense. What do we get? 35.8? 35.8. You see how going from the y-axis rotating to that green line is smaller than rotating to the original 1p. So it makes sense we got a smaller value. Okay. So that's the speed, and it is at a bearing of 35.8 degrees. Okay, how we doing? Okay. Are they starting to make a little more sense? The good news is they work the same way. You find your two vectors, add them up, find the magnitude and angle measure of that one. Okay, so let's try this one. Now, let me go ahead and give you about, let's say 4 minutes, okay, to try this problem right here. And at the 2-minute mark, we'll go ahead and stop just to see if everybody's on the right track. Okay, and let me get my timer here. So let me go ahead and read it before I start the time. It says, Bert and Ernie meet up to fly a toy helicopter. At full power, the airplane can fly 100 kilometers per hour in calm air. Bert has the controls and he makes the helicopter take off heading 45 degrees north of east. So said that way, 45 degrees north of east, that's the same, as saying north 45 degrees east. So that's in the second quadrant? So east is to your right. Yeah, so if we're looking here, north, south, east, west. So it places it in quadrant 1. So that's a quadrant bearing, right? Again, it's just the way that it's said. After he feels comfortable with the controls, he turns on full power. A steady wind begins to blow from north to south. Okay, so again, from north to south, so the wind is actually blowing south, right? At a speed of 32 kilometers per hour. In what direction and what speed is the helicopter traveling now? So let's go ahead and say we have two vectors here. Let's say H represents the vector representing the helicopter, and then we've got W for the wind vector. So we'll go ahead and start there. All right? So I'll go ahead and give you 4 minutes. Remember, even if you're not sure how to get to the final answer, take it one step at a time. Okay? Let's start with seeing if we can just get the component forms. Okay? The only thing for this formula, magnitude cosine theta, magnitude sine theta. Okay? Remember, theta is going to start rotating counterclockwise from standard position. We have to have that value of theta. What's up, sir? You need a calculator? Yeah. There you go. Okay, it's 2 minutes. I'm going to go ahead and stop it there. Let's see if we're all on the same page. Okay. So let me go ahead and redraw this diagram right here. We know we're going to be in quadrant 1. Okay, now it says the plane takes off north 45 degrees east. So let's say this represents, or I said plane, helicopter. It's going 100 kilometers per hour. Okay, so this rotation here is 45 degrees, right? But now remember, we need the theta measure. But in this case, it does turn out to be what? Yeah, 45 plus 45 is going to be 90. So actually in this one, it is appropriate to go ahead and use the degree measure that I'm given. So how am I going to fill in this formula? What's the magnitude of the helicopter? Okay, so it's going 100 kilometers per hour times the cosine what? 45, comma, 100 sine of 45. Just like that. Okay. Now we can easily go ahead and figure out the decimal value for each of those. Now the wind, it's going from north to south, which means it's actually blowing due north. So if it's blowing down, how fast is it going? 32 kilometers per hour. What do you think his component form is? 0 what? Oh, now be careful. 0.32 would have him going north. We would indicate he's going south by making it negative, because the only way to go down is to have that value as a negative. Okay. How do we do with the component forms? How many people had those set up right or really close? Okay. All right, so let me go ahead now. In order to find the resultant, what am I going to do with these two vectors? Add them up. H plus W. So we'll find the decimal values of those, and we'll end up with, some component form. Now, once you have that R, that vector, you find the magnitude and theta. That should be able to help us get the question. Okay, so let me go ahead and start the timer again. 2 more minutes to finish up. Now remember, your direction, we always want to keep it consistent with the problem, the way it presented it to me. So because it gave me direction as a quadrant bearing, we want to make sure that our answer is going to be a quadrant bearing. Okay. Let me go ahead and get rid of this. Okay, go back over there. Antonio, you doing all right? All right. I'll go ahead and put a decimal value right there. I should be able to squeeze that in. Okay, remember, it just takes a little bit of practice. You'll be able to use your notes on quizzes and tests. In fact, on the homework, you've only got one, or I believe two word problems like these. Okay, only 2. The rest of them are just skills, using the formulas, applying the definitions, and so forth. that is a full 4 minutes, and if you're not done, that's okay. Let's go ahead and first figure out what those decimal values are for the 100 cosine, 100 sine. So let's see here. 100 cosine, 45. So I'm saying about 70.7. Okay. And then 100 sine of 45. So 70.7. Now, does it make sense that these two are going to be identical? What's happening at 45 degrees? Remember, do you remember that coordinate there? Both x and y are square root of 2 over 2, so they're the same value, so it makes sure we get sense that we get the same decimals. So on each of these, I'm going to go ahead and say 70.7, 70.7. Now, in order to get the resultant, I'm going to take these two vectors, I'm going to add them up. So 70.7 plus 0, 70.7 minus 32. Okay. So we know the plus 0. Let me take this one out here and go ahead and subtract the 32. So I'm going to say 38.7. Okay. So 38.7. This one was 70.7. This is what's going to get me my answer now. That value of A and B. Okay. Any questions on what I did there? Okay. Well, how do I find the magnitude? How do I find the actual speed that the helicopter's traveling? Okay, so remember, that's the magnitude. This thing will go, there we go. So the magnitude of R, square root of A squared plus B squared. Remember, this is your A, this is your B. So the square root of 70.7 squared plus 38.7 squared. Okay. So let's see what that turns out to be. 70.7, that's not a point, 0.7 squared plus 38.7 squared. So what should I be getting when I push enter? What are we getting? 80.6. Okay. I would say that's absolutely correct. 80.6 kilometers per hour. Okay. 80.6 kilometers. Oops. There we go. Now, how do I find the direction angle? Tangent inverse. Okay, so the formula is tangent theta equals B over A. But Angel is saying tangent inverse of, now remember, B over A. 38.7 over 70.7. That's going to give me theta. Okay, so I'm going to go ahead and come on over here. Let's see. Tangent inverse. What was it? 38.7 divided by 70.7? Okay. All right, so I'm getting about, let's say, 28.7 degrees. 28.7 degrees. Now, here's my question. 28.7 degrees. Will I go ahead and say that my answer is north 28.7 degrees east? Or am I forgetting something? Would we need to do that? Yes. Okay. Okay, well, let's talk about why. Now remember, this angle theta for these two formulas right here, theta will always start what? It always starts from the positive x-axis, standard position, right? So what we just found, 28.7, let's say that's this right here, 28.7 degrees. Okay. Now remember, we want our answer as a quadrant bearing. Quadrant bearing always rotates off the y-axis, whether positive or negative. So since we're going to be in quadrant 1, it's definitely going to be north. I would have to rotate right, but the question is, how far right am I rotating? And Brandon's absolutely right. We would have to subtract that from 90. Okay, so 90 minus, what do we got here, 28.7. So that's going to give me 61.3. So 61.3 degrees east. That is what I would be looking for. Okay. That's the only thing that can really get tricky on these problems, is making sure that you're giving your degree measure the same as how it was provided to you in the problem. Okay. How we doing? Okay? All right. Well, you'll notice there's a third problem here that I'm not going to work with you. Same type of setup, but you'll notice I've already given you what? I've already given you the answer. So, excellent opportunity. Try it. It only takes a few minutes. Okay, work through the problem and see if you're getting that result. If you are, fantastic. If not, come see me. Let's see where we made a mistake. Okay. Last thing I need to show you on our notes here is what we call rectangular components. Okay. And this is in the packet that I gave you just a few days ago with the word problems. So two or more vectors with a sum that is a vector R are called components of R. While components can have any direction, it's often useful to express or resolve a vector into two perpendicular components. The rectangular components of a vector are horizontal and vertical. So in the diagram, the force R exerted to pull the wagon can be thought of as the sum of a horizontal force X that moves the wagon forward and a vertical component force Y that pulls the wagon upward. So if you take a look, she's pulling the wagon in this direction, right? Okay, pulling it horizontal and up. Well, those two vectors are working together to give her that diagonal force. That's what we're saying here. In fact, does that variable R sound familiar? Yeah, that's what we were just talking about, the resultant. But what we're saying is that a lot of times it's much easier if we go ahead and make a right triangle using that vector. Okay, so let's just get right to an example and let me show you. It says a player kicks a soccer ball so that it leaves the ground with a velocity of 44 feet per second and an angle of 33 degrees with the ground. Draw a diagram that shows the resolution of this force into its rectangular components. Well, I've kind of already got you started here. Let's say here's the ground. Okay. And when the ball is kicked, it's going to go ahead and follow a path like this. And ultimately, you know, it's going to turn into a parabola, but we're just talking about initially. Okay, when you first kick it. Let me get rid of that. Okay, so what incline does it have with the ground? 33 degrees. Okay, so all I'm wanting to do is take this vector and rewrite it in terms of component vectors. These vectors that form a right triangle. Now, how hard was the ball kicked? How fast is it traveling? 44 feet per second. So I'm going to go ahead and say 44. This speed represents the magnitude of the soccer ball. Okay, the speed and the direction that it's going. Is everybody okay with that? Well, for these problems here, all you're trying to do is find out, okay, if it's moving 44 feet per second diagonally, how fast is it traveling horizontally? How fast is it traveling vertically? To give me that original vector. And this is just right triangle trig. Okay. In fact, let's say I want x. What does x represent to 33? Think way back to when we first started talking about trig. What were the three sides of a right triangle? One started with an O. We have the opposite, the adjacent, and the hypotenuse, right? What's x to 33? He's the adjacent. Y would be the opposite, and 44 would be the hypotenuse. So what trig function could use the adjacent and the hypotenuse? Oh, not tangent. That's y over x. That's opposite over adjacent. I'd say cosine. Remember, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. So I could say cosine of 33 degrees is equal to x over 44. So how would I solve that for x? Yeah, just multiply through by 44 times 44. Okay. So when those cancel, let's see, how fast is it traveling horizontally? Well, I would say 44 cosine, what was it, 33? Okay. So I'd say horizontally it's traveling about 36.9 feet per second. So we can probably just go ahead and say 37. 37. And this is feet per second, correct? Yes. Feet per second. Now, we found x. Well, what trig function could I use to find y? Sine, yeah, opposite and hypotenuse. So sine of 33 degrees is equal to the opposite over the hypotenuse. And I would solve this the exact same way. I'd multiply through by 44. Okay, so let's see what we got here. 44 sine 33. So how fast is it traveling vertically? That's a good point. Nobody's got it in on their calculator yet? I heard 23.9. There we go. Now, 0.96, we could probably even just make a case for 24. There you go. So y is about 24 feet per second. There you go. I could. Oh, am I confusing you with that?
Yeah.
Okay, then I'll go ahead and put the line. Marcus, you want the line too? Or was that Andrea? Oh, I thought that was Marcus. Sorry. Well, I looked. You're the first person I saw when I looked over there, and all I heard was. I thought, okay, Marcus, you doing okay over there? All right. Okay, here's our last example. Heather is pushing the handle of a lawnmower with a force of 450 newtons at an angle of 56 degrees with the ground. Okay, so we're pushing a lawnmower, right? So let's say we have the handle right here. This is going to be an amazing looking lawnmower. Let's imagine the person is really tall who's doing it. There you go. Okay, so we have the lawn. That's a lawnmower. So there you go. Yeah, here we go. So now think about it. You're pushing a lawnmower. I want to go ahead and break this down into a right triangle. Okay, so we're pushing it like this. So vertically, am I actually pushing it up or down? I'm pushing it down. Horizontally, am I pulling it towards me or pushing it away from me? Okay. So you see how I'm making sure to have the arrows fit the direction that we're going? Okay. What angle is it making with the ground? 56 degrees. And this time, okay, our magnitude is a force in newtons. So this is 450 newtons. Well, even though the magnitude is different, it's still the same type of problem. Let's say this represents x newtons, this represents y newtons. The other problem was just talking about the speed of the object. Okay. Well, what do you want to find first, x or y? X. Okay. So, what can I use to find x? Cosine. That's exactly right. Adjacent over hypotenuse. So cosine of 56 is going to equal adjacent over hypotenuse. Okay, multiply through by that 450. So somebody help me out. What would x be? 450 times cosine 56. 251.7? Okay. So Christian says 251.7 newtons. Okay. What can I use to find y? Okay. So I would say sine 56 degrees is equal to the opposite over the hypotenuse, where once again, 450, 450. Those are going to cancel. 373, would you guys agree? 373 newtons. There we go. Just like that. Okay. Perfect, 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 perfect. Okay. Any questions? Do we feel a little better about those word problems? Does that kind of help? Okay. Man, time flies when you're having fun, right? Look, it's already 28. So I'll tell you what, we have just enough time. Is there a question you're looking at on the homework that you're thinking, we could probably use a little help on that? I wish we had time. Yes, yeah, we're right on the 10 minutes, so you can run real fast. Mm-hmm. All right, so let me scoot on down here. There's the word problem. Okay. So let's see here. Maybe I'm thinking maybe go ahead and helping you with 6 or 7, because I could see that potentially kind of confusing some folks. But I mean, I'll work whatever problem you'd like me to. Okay, number 6. There we go. Find the values of A and B such that W is equal to AU plus BV, given U is 1, 4, and V is -2, -1. Okay, so really it's the same thing as the previous section. You remember where we had component form and you show me double this vector. Show me 2U plus 3V. It's that type of thing. You're almost on the right track. Okay, so let me start with this right here. They're basically giving you the formula, right? The equation. W is equal to AU plus BV. Okay, well, we know W, that's -7, 7, is equal to, we don't know what A is, but do we know U? It is 1, 4. Plus BV, so I'm going to go ahead and say B times vector V, -2, -1. Is everybody seeing what I'm doing? I'm just plugging the vectors into the equation. Okay. So what I would go ahead and do, what do you do if you have some kind of value outside a component form? You just go ahead and distribute, right? So I'll distribute the A. I'll distribute this B. So I have -7, 7 is equal to A times what? A. And then we have 4A. Okay. Plus -2B, or not 2B. A little bit of Shakespeare there for you. And now here's the thing. How do I add vectors? Like, what do I do? How would I add 2 vectors to get -7, 7? Well, here's the thing. What would I add A to? It would correspond to -2B, right? But in the answer, it corresponds to -7. So see, I would have -7 equals A minus 2B. That's exactly right. So now 4A corresponds to -B and the +7. So this says 7 is equal to 4A plus B, or I'll say minus B. Okay. And do you recognize it? Starts with an S. It's a system. Okay. And there's any number of ways you could solve a system. You could use elimination. You could use substitution. Probably elimination is the fastest. Do you want to be able to add these and get rid of A or B? Okay. You want to get rid of what, man?
I think the answers are 1 and 3.
You think the answers are 1 and 3? How'd you get that? Oh, you're just kind of visualizing it?
Yeah.
Okay. Well, let's say I go ahead and take the second one and I multiply by a -2. Now here, okay, let's talk about that. The first one I'm not touching. -7 equals A minus 2B. But now if I distribute, -14 is equal to -8A plus 2B. Well, you're solving a system. Okay. Now, why did I choose to multiply the second one by -2? What happened when I did that? There you go. See, that's why we call it elimination. If I had wanted to eliminate A, I probably would have multiplied the first equation by -4. You want them to be the same value, but opposites. Okay. So let's see here. -14 plus -7 is a -21, which is equal to negative 7a. So when I divide through, a equals what? 3. Well, see, now all I got to do is plug back into one of my original equations. If I know that 7 equals 4a minus b, and we just found that a is 3, 7 equals, what's 4 times 3? 12 minus b. Well, 12 minus what is 7? 5. So b is 5. This one just kind of incorporates an old idea, you would have seen in Algebra 2. That just means it's fun. All right. Okay. Thank you so much, guys. Great job as always. Remember, this is due on Monday. We'll come in, grade it, talk about any questions you have.